Hey everybody, I'm going to go over the 8.1 homework quiz solutions, but I'm also going to do a quick overview of 8.1, the textbook work, because I had a few people ask me the same questions. I just want to make sure to clarify some things from the book. So I just took some screenshots of the highlights of 8.1. And the first is a definition for a point estimator or a point estimate. For us, our point estimates that we're going to use are either going to be p-hats. That's considered the best point estimate for a population proportion. So p-hat is the best point estimate for a proportion. That's a sample proportion. And then the sample mean x bar is going to be our point estimate for means. So we won't know the population parameter, but we have these sample statistics to estimate them. They are the point estimates, our best guess at the value of some unknown population value. Now, because this is a sample value, because that's a p-hat or an x bar, it's not likely to be the true population mean or the true population proportion. So because it's not exact, we do our best thing at finding a range of values or an interval of values. So what a confidence interval is, it's that same point estimate, but we add or subtract a little cushion. And that cushion is based off of what we know about the sampling distributions from last chapter. So it's going to be the point estimate plus or minus some margin of error based on some confidence level. If I kind of try to draw this in a picture for you. So let's just stick with proportions. That'll be 8.2 stuff. So we'll have some p-hat, and we'll add or subtract from that some margin of error, and you'll see in the notes tomorrow, or we've done it first semester, that margin of error is going to be z star times the square root of p hat q hat over n. And this p hat q hat over n should look familiar because that's the standard deviation or standard error for a sampling distribution of proportions. So you have, remember all those p-hats from the AP stat guy. I have some normal curve of a bunch of p-hats piled up, and now they're going to fall around some population parameter p. We just don't know that p now. So what happens is I pick some random p-hat. Let's say I pick this p-hat up here. I don't know p. Like, this is the true p that exists. That question mark is some existing population proportion, but I don't know it, and the best thing I can do is find this p-hat and create a range of values to try to capture that p. So this interval, let's say if I add a margin of error and subtract it, I get values between these green parentheses. That's my confidence interval, and this one happened to capture the true population parameter. Won't always capture it. And then I had a bunch of questions about how to interpret confidence level. Actually, I'm going to stop here. I'm going to jump to the 8.1 quiz and kind of go over those two, or the first two parts of the first question. So here in 8.1, quiz B, crop researchers are interested in the productivity of a new variety of corn. They plant 25 plots. This looks familiar to last week's work. 25 plots, that's N, with randomly selected seeds. Record the yield in bushels per acre and find that a 99% confidence interval yields the true mean is 118 to 130 bushels per acre. And the first question, so here's the confidence interval. And the first question is, what's the point estimate? Well, when I create these intervals, and this one happens to be how it means. So in this problem, they sampled these 25 and they randomly selected seeds, and they calculated some value for x bar, and they added a margin of error, and that gave them 130 on this end, the high end, and they subtracted, and this is backwards math, but just think going the other way, they did x bar minus this margin of error, and that's where they got 118. So that point estimate is this value right in the middle. So how do you find that value in the middle? Well, what value is halfway between 118 and 130? That is 124. So the x bar here is 124. That's the best estimate for the population mean. We created this interval around that point estimate. Now the margin of error is, well, what is this cushion? Let me go back to what I created here. What is this cushion where I added and subtracted the margin of error? So if this is 124 in the center, because it's halfway between 118 and 130, well, what is this green circle that I added, and what is this green circle that I subtracted that gave me the interval? Well, those green circles are my margin of error here, is plus or minus 6. Because that's how much was subtracted to get 118, and that's how much was added to the point estimate to get 130. You really don't even need the plus or minus. I'm just showing it. That's where the 118 and the 130 came from. Interpret the 99% confidence interval in context of the problem, and then D, interpret the confidence level. So I'm going to jump back to some of the notes highlights that I picked out. This is straight from your textbook. So there's a difference between the confidence level and the confidence interval itself. So the range of values we create is a confidence interval. And you remember this from first semester. I made you guys interpret, especially if you were going on to AP. To interpret the confidence interval, you'd say we are, I think it was a math libs I gave you, we are blank % confident that the interval from this to this captures the true population parameter in context. We had a similar math libs first semester. So that's what your actual interval means that you picked. Now to say your some % confidence or your confidence level, that means if you were to create infinite, well here it says all possible samples. So you take all possible samples in the same way and you calculate all these sample statistics and you create intervals. So I create infinite intervals. The level of confidence is how many of those intervals would have captured the unknown parameter. And I have this applet. I remember I showed you first semester. But here is an applet that kind of simulates this. So let's do the problem we we're just looking at. So let's do means. I think we calculated that mean was 124. Standard deviation is not quite 6 because I have to divide it by the square root of 25. I can figure it out real quick. I just calculated the standard deviation. No worries of how I did that, but I did it based on the information they gave us. So let's say I create 100 intervals. So this is taking samples of size 25. Let's say the true mean, I just picked 124. Let's say the true mean was, I don't know, 120. And I sample all these intervals. This level of confidence of 95% means 95% or 95 of those 100 intervals should capture that 120. And if you see what I create here, this one was exact. It's not always exact. So if you look at these graphs, what these each mean is here's my my interval. So I create these point estimates and I make an interval around them. These are all my point estimates piled up. So notice the ones in the red are the point estimates that when the interval was created around them, they missed that true population parameter of 120. And if you look, the kind of green and the red coincide in this picture on the left. So that's really what we're doing here when I say, or what we're talking about when we say level of confidence versus interpreting the interval. So if I go back to part C, and I'll type this instead of write it to save a little time. If I want to interpret the 99% confidence interval, this is the math libs. We are 99% confident. The interval from 118 to 130 captures the true mean number of bushels per acre. What was this? Bushels of corn. For the new variety. And then versus the confidence level. So the confidence level means if we reproduce the interval many, many times, created many, many intervals of this size and in this manner, we would capture, or we expect to capture, the true population mean in 99% of intervals. So that's the difference between the confidence interval versus the confidence level. All right, here's question 2. A university health services physician is concerned about how much sleep freshmen are getting in the first few months of school. She asks a simple random sample of 20 students how much sleep they got the previous night and constructs a 95% confidence interval for the mean amount of sleep in hours. Discuss whether this study meets the necessary conditions for constructing a confidence interval. If you think one of the conditions has not been met, what additional information will be required? So let me go back to the book stuff that was important. I thought I copied the conditions. I mustn't have. But the conditions, if you read 8.1 and you took good notes, the conditions for confidence intervals are the same as sampling distributions, except there's one more condition, a random condition. So if I have to check all these conditions, the first one is random. So was the sample random? It says yes, this was an SRS, so we need to say that. The normal condition for means is the same as it was for sampling distribution, meaning we have to be told the population's normal or the sample size has to be bigger than 30, or at least 30. And here my sample size is 20. So this condition is not being met. So normal is not met because the sample size is too small. And we're not told the population shape. And then last, independent, same as last chapter. 20 students. I would say 20 students is less than 10% of all students. In the population, or it's freshmen. B, if instead of constructing a 95% confidence interval, we constructed a 90% confidence interval, would the 90% interval be wider, narrower, or the same width? Well, let's think about what that means. And I'm going to kind of go back to old school empirical rule. So empirical rule, if this is the mean in the center, every standard deviation away, I kind of get wider. This interval gets wider. So if you consider this the point estimate, well, 95% is in here. We know that's in 2 standard deviations. And 90%, if you were to find that value, it's going to be inside. It's going to be between the 68%. So this interval is going to get narrower. So the blue would be the 90% confidence interval width versus the red being the 95. And they got their pluses and minuses, like the goods and bads of having a wider or narrower interval. And you'll kind of see that a little bit further on in the chapter. But here you would say it's going to be wider. Sorry, narrower, just kidding. And just to save a little time, because I'm up to almost my 15-minute max, it's going to be narrower because the center of my curve, 90%, is less area than 95%. How would the width of the confidence interval change if the physician took a larger sample? Explain. Well, again, if I draw another normal curve and you think about standard deviation and sample size and how that all is affected. So if there's my point estimate or my mean in the middle, when I add or subtract this margin of error, you got to think about what these formulas look like from last semester. And they did introduce them briefly in 8.1. The formula will be plus or minus sigma over the square root of n. So if we made this n bigger, that makes this fraction smaller, and it'll make the margin of error smaller. So meaning the amount I add or subtract from either side of that point estimate is going to be smaller. So here you would say the width would get smaller, and for that reason, that it would decrease that standard error or that margin of error. I'm going to also post a video of the AP Stats guy for tomorrow. Please check it out.